All right, here's our problem. It says a person pushes a cart with a constant force of 120 newtons at a constant angle. So just breaking that off, we've got 120 pounds of force. Sorry, 120 newtons, not 100 pounds. And it's got an angle, so theta is at 45 degrees. It says find the work done in joules moving the car to in 10 meters. So one thing to note before we get started is that work is measured in feet per pounds. However, it's also measured in Newton meters, which is actually joules. So when we find the force times that angle measure, that's going to give it to us in joules, so we won't have to convert anything. So that's the first piece. Okay, there are two methods to do this. I'm going to split it up, and I'm going to show you both methods. So method one is using the projection formula. So by the projection formula, we've got the magnitude of projection F onto AB. So W equals the magnitude of projection on AB times our vector AB. That's using the projection formula. Plugging it in, we get 120 cosine 45. This is taking it back. Times AB vector is actually 10. That's what it says, 10 meters. That's how long the vector is. So when you plug that in, you get about 848.5 joules. Now, that's method one, and that's it. Method two is using the dot product, which is the second way on the prior slide that it shows that you can solve it. So we're going to say W is found by force times AB, sorry, not times, the dot product of force and AB. We need to write the component form of our vector F. We don't have it in component form, but how to do it, if you look at that right triangle, that's where we see that we do 120 cosine, and it's actually negative 45 degrees. Based off of starting from the true bearing and going backwards. So negative 45, comma, 120 sine negative 45. That's that vector. And that is our force in component form. And then vector AB is in the form of 10, comma, 0, as it's going 10 and not moving up or down anything. So that's the vector. Oops, I don't need to rewrite that. Hold on. There we go. Okay, so now we can do the dot product of the two. So that means we're doing 120 cosine negative 45 times 10, which is 848.5, which you can see that's exactly what that is right here. And then 0 times the sine piece with 120, which is 0. So we get this, which just shows that we've got 848.5 joules of force or of work pushing the car. So two different ways. As you can see, the dot product way kind of has a little bit more steps to it. And the projection one is just cut and dry, looking at magnitude and not having it in component form. So two different ways to do it. You guys can pick the way that works best for you. They should, if you're doing the correct work, get the same answer. All right, that's it.